Let's get a little bit more into switch security. I've mentioned SSH and Telnet, so let's go ahead and configure some SSH, and I'll talk a little bit about different types of security attacks that could happen, and we'll go from there. So let's put a switch out here into our ether, and then we'll wait for that to boot up. So why would I want to configure SSH? So remember I was talking about Telnet being insecure. So actually, you know what? Let's show that. We might as well show that. And I'm going to do it in GNS just so I am not doing favorites for anybody. So let's get this started up. And then we'll add a cloud. I'm going to connect this to my network. And then we're just going to use the default interfaces. So we're going to go into our first interface, which was the 00. Is that right? Yeah, it was. All right. So interface 00. And we'll give that an IP address of then we'll no-shot that. We'll go into our line VTY, and we're going to set that up for password auth. Give it a password, and we'll tell it we want to do login. Gonna check. Here we go. 00 is up. Let's see if I can get to it. I suggest as you go through this, don't save. My recommendation is do not save your topologies that you create. Start out every single time with a blank slate. You're going to say, man, that's a lot of typing sometimes. When we get into the future videos, you're going to say, man, that's like 4 routers I got to configure. Do it. Honestly, do it. Because when you get into the exams, if you go and take the exams, you have to get this down pat, and it needs to be muscle memory. You need to just be able to spew out a bunch of commands, get it going, because there's going to be times you're going to mess up, or you have to troubleshoot something that's already messed up for you. You want to be very good at the commands. This needs to become second nature to you with the different hierarchies of how this configuration prompt works, and being able to just configure something, the basics very quickly is crucial. So please spend the time and just keep doing it over and over again, repetition. Okay. So we have that up. Let's see if my Telnet works. Good, Telnet works. So now I'm connected to that. So let's exit out. And this is pretty cool. I'm going to show you this. Now, if I wanted to check these packets that are being sent and received from this virtual router, one way I could do that would be running Wireshark on my own computer here and take a look at what's being sent and received. What's neat with GNS is I can actually right-click on a link and say capture, and I can say, okay, what interface do you want? Sure, and it's actually going to start capturing that interface with an actual PCAP file, and then I can right-click on it again and say start Wireshark. So if you have this installed, look at that. This is live, happening right now from my computer to this virtual router. That's pretty cool. So now what I can do is I'll bring up my terminal. We're going to do a Telnet connection. There we go, and then we'll stop this. So let's take a look for that. I follow that Telnet connection that I just did, look at that. Everything is in clear text. What the router gives back to us when it asked for a password and the password I actually entered. Everything is clear text. That's why I'm saying this is insecure. Even if it's on your local network, if someone out there is disgruntled or something in your organization and they have some way of, you know, tapping this line or doing a mirror off of a port or something like that, they can take a look at what's happening. So make sure it's encrypted. So that's why we're going to talk about SSH here. So I wanted to show that to you, that you can actually see that traffic, and you can find it by browsing through here too. There's the password prompt if you look at the data down here, and then if we just keep going along, we'll find the actual password. Actually, looks like it was these. There's the $, and then there's CISCO. So that was send a packet for every keystroke. So there's our password. So, and I also wanted to show that functionality that you can actually do that in GNS. It'll capture with Wireshark right off of a link. It's pretty cool. So we can stop our capture. We'll just close this out. And then we'll go back to our packet tracer. Alright, so let's configure SSH. This will work on not just a switch, but a router too. So this goes for any iOS device. So let's go into enable mode, and let's show what we have currently. So if we do show IP SSH, it'll give us what we have available. And right now it's yelling at me because I need to create RSA keys. So, but it'll say here's the version, you know, that we have available, and it's disabled. So let's go ahead and configure this. So let's go into config mode, and we need to create a domain name. So we're doing RSA keys. We're using SSH here. You need to make a domain name. So you can make up whatever you want, honestly, or you can make it match your internal organization's domain name and get fancy with it. But we could say, you know, this is cisco.com. And then we're going to execute crypto, and crypto is the part where it's going to start generating this key for us. So we're going to say crypto key generate RSA. And I should note here, make sure you know these commands. These are very crucial. I'm sure there will be a question about this. This is something that everyone needs to do. So I would not be surprised if they want you to configure SSH or something like that. Okay, we got to change the host name first. It doesn't like my defaults. There we go. So change your host name first. Alright, so how many bits do we want? It's recommended to choose a larger value, such as 2048 or 1024 or something like that. The lower values have been considered insecure by now, so I would say go with the higher bit values. If you're going to be using SSH, the processing is minimal anyway, so you know, go with the higher level key so it's more secure. Now we have to create a local username. When you log in with SSH, it's going to require a username and password authentication, not just a password. So remember I mentioned the login local before. When you do that, it's going to check its local user database. That's what we're going to do now. So we're going to make a username. So username is Andrew, and my password is Cisco. So there we go. So now I've made it. Look at that. SSH has been enabled because I've created a username. So now let's go apply that SSH to some sort of interface. So how do we do that? We're going to do that to our line VTY, our good old friend line VTY. So line VTY 015, and we're going to configure the first 16 connections to use SSH. So transport input SSH, and we're going to tell it to use SSH. You can also do transport input other things, such as force it on Telnet, or tell it none or something like that. By default it'll do Telnet, that's why we didn't do it before, but in this way we're specifying it has to be SSH. You cannot use Telnet anymore. So transport input SSH says use SSH only. So now we're going to say login local. If you forget this last command, you're going to turn on SSH, but you're not going to be able to connect because it's not going to be checking against the user that we just created. So make sure you execute login local. At this point, we should be able to get to it over SSH. So let's create a computer real quick, and we'll see if we can make it work. Alright, I don't have anything on here, so let's do that VLAN 99 again. So do 50. We're going to do our first interface. Say make it a member of that VLAN. So VLAN 99 is up, but we have to just connect it now. So now we're going to connect it. Hopefully that comes up. So we're negotiating right now, and STP will kick in a few seconds here. Alright, good. So now on our PC, there we go. So now it's going to ask me for my password, which is Cisco, and now I'm in my switch. So that works out pretty well. I cannot do enable though because I didn't set a password for it, but we do see that SSH works. You can also specify the SSH version that's used. You could choose 1 or 2 depending on what your needs are. 2 is considered newer and better, but 1.99 is fine too. So now that we've seen that SSH works, let's talk a little bit about the common types of attacks you might be trying to mitigate. So one of those is MAC address flooding. So let's go into our CLI here. This will fail eventually. MAC address flooding is caused by generating thousands and thousands and thousands of MAC addresses and sending them out onto the wire. And that causes a switch to learn way too many addresses, and it overflows its CAM table. So a switch has that CAM table that tells it what MAC addresses are on what ports. There we go. So let's show our MAC address table. So right now it has none, but what you would see is thousands and thousands and thousands of MAC addresses on probably one port, unless there were several computers doing it, that would potentially overflow the CAM table. And if the CAM table overflows, it'll either crash the switch and completely kill it, or it'll put it into fail open mode. And when fail open mode is turned on, it makes the switch act like a hub, so it doesn't have any intelligence built into it anymore. It'll flood all the frames everywhere, so that'll not only flood your network and make things not run as nicely as you were hoping, but it would also allow them to capture any traffic they want, because then any communications going from any computers on that segment would then be flooded out to every other port, so then they could be using Wireshark, for example, and capturing all that traffic. So what you can do is mitigate that with port security options, which we're going to go into in the next video. So you can tell it to limit the amount of connections and the amount of MAC addresses learned on a port and things like that. Another one is Dhcp flooding, or Dhcp spoofing, I'm sorry. An attacker floods a DHCP server with requests, and it'll use up all the leases. So remember we were talking about DHCP, and it'll give out IP addresses to the different computers, but it only has a certain number of leases. And for example, on this network I just created here, we have 254 usable addresses. So if they do a request for more than 254 addresses, then they used up all of the IPs on the network. So one other thing they could do, not just that, and that would just be kind of a denial of service method. One thing they could do is set up their own DHCP server, so they could connect their own PC into this switch and then run a DHCP server off of this computer. And then they could provide leases to computers that were coming online by trying to they could combine that with some MAC address spoofing, where they could tell the switch that they might be the previous DHCP server, and then they'll also try and respond to any requests that come their way for DHCP, and then potentially give those clients a DNS address that then routes all traffic through that PC for DNS. So then they could capture where they're going and things like that as well. So they could potentially not just do DNS requests to it, but they could even do gateway. They could send the DHCP lease to a client and say, sure, come talk to me for your gateway needs. And then they'll capture all the traffic and then potentially route it out where it's supposed to go. But they'll capture all that first with whatever capture tool they want. Another one is CDP. Cisco Discovery Protocol is enabled by default on all ports, and it'll send out a little frame every once in a while looking for neighbor information. So if I had another switch connected here, it would show. And you know what, let's do that. We'll connect a little switch here. And it does not need an IP address, because CDP runs on layer 2. Look at that, it already came up. So there's the other switch. I'm on switch 0. This is showing me information about switch 1. It says here's the interface he's connected on. This is the model that it is. It'll give us information like that. You don't want that enabled on your access ports. So any of the ports where a PC might be connected, well, they don't need to know CDP info. That it's not necessary. And even between switches, it may not be necessary. It's nice for diagnostics on occasion, but it's not critical. So it's recommended to disable it, or just disable it on the access ports at least, so that that traffic is kept within your core of your network. Another thing you can do to mitigate some issues, such as someone connecting in their PC to a switch unannounced, is to disable unused ports. So any ports that you're not using, go in and do a shutdown command on them. Now that takes extra effort from the administrator's side, because if you have hundreds of switches out there and thousands of ports, well, that can be a nuisance, but that is something you could do. We can also do port security features, which we're going to talk about next, and access control lists. So you can do like a basic firewalling on a router or a layer 3 switch or something like that. You can lock down the type of access that's being requested. So we'll talk about some of that coming up as well. Make sure you encrypt your passwords. Remember, we did service password encryption. So that's nice for over-the-shoulder glaring eyes, but it doesn't actually solve the issue of fully encrypting the password. So make sure you use the enable secret. As for login passwords and such, those are stuck using the semi-secure method of the service password encryption, but usually people will use AAA or some sort of radius server to allow access for management to their devices, and all those will be stored, in their secure server, so it won't be as much of an issue. But the local database is not the most secure method of storing for storing users. Control your physical access to devices. So we don't want to prevent someone from even getting to your switch to plug into the port in the first place. Make sure you lock your cages. Keep people out of your IT closets. I know in small environments that's hard. Often it's used as a storage closet too, but do what you can. There's some security tools you can use that'll help you along your way as well, and I brought up a couple of these here. One of the famous ones is Nmap. It's a security scanner. It's a really great tool, and it allows you to do all sorts of port scanning and IP scanning across your network. It'll even try to figure out what operating system's being run based on what responses it receives and things like that. This is a very powerful tool. There's books out there for it that are hundreds of pages thick. Give Nmap a try if you're looking to do something. It's freely available. Another one is Nessus. So Tenable is a company that makes this product Nessus. You can get a free license, I think you still can, for a single person if you're an individual, and it does a similar thing where it does like an Nmap type scan, and it does a vulnerability scan of your network. If you're more into the penetration side of things from like a code aspect, Metasploit is a great tool, also freely available. So you can test your applications and such for vulnerabilities. Nmap's more of a network vulnerability scanner, and Nessus is, and then Metasploit's more of an application vulnerability tool. Another great resource, which includes all these things, is Kali Linux, and this originally was called Backtrack Linux. So if you look here on this little download icon, it's got a dragon. That's the icon used for Backtrack Linux. Backtrack has died off in favor of Kali. It's the same group basically. So if you're looking for Backtrack Linux, the newer version, it's now this. It's Kali Linux, and this is a bootable Linux distribution that you can put onto a CD or a DVD and boot it up on any sort of PC, and you can get a whole suite of tools that are freely available, such as Nmap and Metasploit and things like that. And it'll allow you to do any sort of penetration security testing that you possibly could want. So it's a great tool as well. So with that, we're going to branch into port security, and our next video will be on that.